Hello. Yeah. So welcome to all of you. This is the third and last of the series of Madhava Lectures. And for those who were not here before, these lectures deal with the history of STEM subjects like mathematics and science. And Sharada's uniquely placed to talk about this because she's both a metallurgist, a dancer, and she's been doing archaeology of metals and the history of the use of metals. So, Sharada.
Yeah, thank you. Yeah, thank you. I'll just try and switch off this. Yeah, thank you. Yeah. Yeah. So, just see if. Yeah. Right. So, thank you. And I now come to the final lecture in the series on a journey through archaeometallurgy of the use of metals, particularly in the Indian subcontinent. And in this final talk, I'll carry forward some of the strands which had been introduced also in earlier talks, and also concentrating a bit more on the ferrous metallurgy later on, and revisiting also a bit on the work on the statuary bronzes, which in a way combines art history and scientific perspectives and so on. And I just saw in the newspaper yesterday, of course, the good news that the silver filigree work from Orissa. Silver, of course, is a metal that I hadn't managed to cover so far. But it was good to see in the paper that the filigree work from Orissa has got the geographical indicator tag, which is given to crafts that have developed in certain areas as distinctive of those areas. So that's a good development. And it's known as Tarkashi, and of course was also popularized quite a lot in the Mughal period. So I just thought I'd start off again touching on the significance of jewelry and ornamentation in antiquity, which was one of the major uses for metals. And you can also see that quite often the styles, there has been some kind of progression over time. So some motifs are carried forward from very early times. So this is the Harappan terracotta mother goddess figure, which is these kinds of terracotta figurines. We don't know if it's a mother goddess, but whatever, anyway, votive terracotta figurine of a female is very commonly found in Harappan sites. And it's interesting also that one of the artifacts which most closely in a way resembles the Harappan votive female figurine is actually found from Adichanallur, the Iron Age site that I had been talking about from Tamil Nadu. And you'll see that some of the things that they do seem to have in common is these very sort of long dangling earrings, and also the prevalence of this belt ornament. And you also see a similar kind of ornamental band, which might have been some kind of waistband, which is also one of the gold finds from Mohenjo-daro here. It is a gold repoussé with a fish motif. And this is actually a plaque made of lead. If you see that the casting, though this seems to be a copper bronze alloy, but kind of similar, very flat kind of casting technique, which carries forward also. And this is a Mauryan plaque of about the 3rd century BC, which looks to me like lead, but we need to analyze it to see. And again, there is some kind of belt ornament. And of course, from the Mauryan period, we also have the very celebrated Bidarganj Yakshi, which is in stone. And you see, of course, this is a Kushan period stone monument with the Persian polishing and so on, but the significance of kind of ornamentation. And there is also this metal, small, tiny metal image, which is in the British Museum from the Shatavahana period, which has a prominent belt sash, and and this is also some earrings from Sutukeni, the megalithic site that I spoke about, and I'd also shown some of the gold mining evidence. This small mistake here, 3rd century BC. And we also have the Roman accounts of the gold from the Nares, which I'd shown the slides from Gudalur and so on, where there was some panning for gold, and which is, of course, associated with the country of the Nares. So, and I'd also mentioned that it's also thought that some of the Ashokan edicts, which we find near Musky and so on, the gold working areas. So the pursuit of metals for ornamentation was, of course, a very important aspect of early mining and metallurgy and so on. And coming back to, since I had been talking about the Iron Age, it's quite interesting here that in the recently excavated artifacts in Adichanallur, they do also reinforce further this idea of the connections with these assemblages, such as the Harappan assemblages. And I'm also pointing to this because we do have this question raised that, because as you see, I'll come to the Chola bronzes, which is what I've really worked a lot about. And I'd already talked about the very early Iron Age heightened bronzes, which have now been coming out of Adichanallur and so on. But we do get asked this question as to, what happens in between, because you do have these spectacular Chola bronzes and all that, which come up in the early medieval period. But is there just a huge gap? But now more and more of these artifacts are being unearthed, with a lot of them having these kind of animal motifs that one can't help being tempted to look back to the Indus repertoire to see where the inspiration is from. For instance, this is a motif that was recently excavated just last year from Adichanallur. You see this kind of interlocking fishes motif. And since I was talking about the bronze casting technique, you can really see how they've used the casting technique also in the design. You have a kind of sprue over here. This is where the metal would have been poured into, the two fishes over here. And normally the sprue can also be cut off, but here it's been left in the decorative design. And there's also this tiny dog. As you know, you get these very tiny animal figurines also from the Harappan repertoire. And particularly, I was struck by this find of something which looks like an ibex or an antelope or whatever. And there you do see that kind of animal also featured in the seals. And this is, of course, a pottery here from Adichanallur, which also shows an antelope figurine and so on. So I think the more we we look at the archaeology, I'm sure now we're finding interesting material coming out all across the country, but generally that hiatus between the Harappan and the post-Harappan also, would probably get filled up with more and more archaeology. Though, of course, it does remain the case that it's really only from the early historic period that you again see a lot of finds of metal, as yesterday I had pointed to the examples of images coming into vogue also with the Gandharan and Greco-Bactrian influence in the northwestern part of the subcontinent and so on. So now I'm going to dive straight back into the Cholas, because there is still some interesting insights to be gained from the use of the study of the metal technology and composition in terms of insights into the art history. And of course, this is a spectacular Brihadishwara temple of the 11th century, built by Rajaraja Choran. And so typically, of course, the Brihadishwara temple celebrates the worship of Shiva as Nataraja. The worship of Shiva in general. And in the heart of the sanctum, of course, you have the aniconic pillar-like lingam, which is worshipped. And the bronzes were actually made as processional icons for worship, and they were taken out in procession and known as Utsava Murtis. And of course, the Brihadishwara temple itself had about 60 metal icons, according to inscription which were in worship. Of these, we can only find 2 which are right now in the temple. And of course, in the Chola inscriptions, Nataraja is known as Adavalan, or the dancer, and he was also the Kuladevata, or the family deity of the Cholas. And you also have the paintings inside the circumambulatory passage of the Brihadishwara temple, which depicts the worship of Shiva Nataraja in the temple of Chidambaram and so on, showing that he was really the most prominent deity worshipped in this period. And here you see a couple of the bronzes which are extant in worship. They're taken out in special festivals. And typically, of course, all around you also have lamps and other kinds of ritual artifacts, which are also part of the temple collection. And this is, of course, a beautiful set of Shiva and Parvati here along one of the exterior walls. And famously, of course, the Brihadishwara temple also had some 400 dancers attached to the temple, and several of the queens and the women of the elite families were also big donors, as well as nuns and the Devadasis or the temple dancers and the Nachiyars and attendants. They also made a lot of donations to the temples. And in fact, one of the dancers, Paravai Nachiyar, is also the consort of one of the Tamil Shaiva saints, Sundarar. So there's also a big role, as I pointed out yesterday, with women also being very active in the patronage of Chola temples and the patronage of bronzes and so on. And just to revisit also, because I had talked about the bronze casting technique here in Swami Malay, and this is the workshop of Radhakrishna Sapatiya Swami Malay, one of the hereditary metal icon makers. And last year, of course, there was a very spectacular Nataraja bronze, which was dedicated to and also installed in the Pragati Maidan and so on. And it was the family of Radhakrishna Stapati that were involved in making this very spectacular casting. And you see here, again, the making of the wax model. And it's interesting that the system of measurement and proportion that they use is what is also called the Talamana canon, but typically they use this palm leaf, a frond of a palm leaf, which is known as the odiole, and it is on the odiole that they mark all the proportions of the icon. And the use of the palm leaf is because it's very flexible, it can be moved in 3 dimensions and so on. So that's how they manage to work out all the proportions, and they generally follow the Talamana canon, where the human body is divided into the 9 talas and so on. And of course, we had seen the casting process using, which has also been described as Madhu Chehiste Vidhana in the treatise Manasollasa written by Someshwara. And of course, Madhu Chehiste Vidhana in Sanskrit literally means the flowing out of wax, because it is the hollow created by the wax flowing out of the mold into which the metal is then poured and the image is then retrieved. And yesterday we were talking about the Chinese technique of bronze casting, which we were saying is totally different. It is not the lost wax casting process. And I was having some discussion with somebody about it. And this is just to point out that in the traditions that you still see in Kerala, it's not at all the Chinese technique, though there may be some confusion because there's a lot of some elements of similarities with Chinese. But again, it's the lost wax techniques which is used here to make large cauldrons, and the celebrated uruli that we know, which was used for temple feasts and so on. And here it is really very important to get a very flawless finish on the wax model. And again, yesterday I'd shown you the use of the lathes, the traditional lathe in turning here and so on. So here, in fact, there's a traditional lathe that's used, and the wax model has been built up on that, and then it is covered with numerous layers of clay, and they finish the surface by using a spatula against a lathe, all hand lathes. And in fact, I've even seen, though I don't see it now, but in Kerala, in Trichure and all that now, this was 2 decades ago, I've seen the final finishing of the metal also being done with a hand lathe and so on. And these are some of these very large furnaces which are used for dewaxing in Manar and so on. And it's quite interesting that in the 11th, 12th century, there are these Geniza documents from Cairo which mention that old metals were being sent to the Malabar and new ones were being made and sent back to the West Asian ports. And these are the accounts of Jewish merchants. So that gives you a sense of the importance also of the craftsmanship and the vessel making traditions and so on in southern India and the Malabar and such like. And here you also see that a wax model of a lamp is also being made. You saw in the Chola temple also the use of these very large kuttuvalakku and so on. And here too the wax model is being made. And here you see the layer of that's to be added right against the final, against which the metal will be cast. That really is the most important. And here they use lamp black and various other constituents so that it becomes a very absorbent surface when they finally do the casting and so on. So, of course, these are some of the grand masterpieces of Chola bronzes. The most celebrated example perhaps is in the Tanjavur Art Gallery, the Shiva as Rishabhavahana, the depiction of the pastoral form of Shiva, and usually that is associated with the bull, and he's seen here with the consort Parvati. And it's interesting that a Chola inscription also mentions that the main deity is usually Ghanamaga, and the Rishabha or the bull is Chaitya. Of course, these are Sanskrit words, and Ghanamaga means dense. So what that's really implying is that the main image was usually solid, and it's only like the bull and so on, or the ancillary images which could have been made as hollow by the hollow casting method. And here in this set of Rishabhavahana and consort from the Natanapurishwara temple in Tandantotam, you can see that very clearly. This is the early 10th century, where the bull, you see that the legs are kind of damaged and broken. And yesterday I had shown you a figure from the northern part of India, that was from Gujarat, where again the limbs were somewhat damaged, because in the hollow casting technique, they would have made a clay core first and then added an iron armature and so on. And there is only a thin layer of wax. And so sometimes, so the metal replaces that thin layer of wax after casting, but sometimes that's a bit fragile and it can be damaged and so on. And that may also explain the preference why the images themselves in the South Indian context were usually always solid cast. And that's what the Sthapati also mentioned, Devasena Sthapati, that they become less auspicious if they're hollow cast. And here you see the very spectacular example in the Government Museum of Chennai, which you all may have all seen, the Ardhanarishwara showing Shiva and Parvati conjoined, and one half sort of seamlessly blends into the other, showing the union of Shiva and Shakti, the male and female principles, as it were. And you also see that the Ardhanarishwara image is also one that is usually associated with a bull. And this is in one of the temples in Kumbakonam, the Nageshwara temple. And this is how actually many of the images look after they are dressed and so on with silk and flowers and such like. But you also see that here Parvati is holding the mirror, because the mirror is also one of the artifacts which have a lot of ritual significance. And yesterday, of course, I spoke a lot about the making of the mirrors, but the mirror is often depicted also in the Ardhanarishwara depiction to separate the male from the female and so on. Now, I think in my first lecture, I had touched upon the global interest that had really brought the Nataraja icon into so many of the museums. And I thought it would be right to touch upon this here at the ICTS, being a Center for Theoretical Sciences, because a lot of the responses to the Nataraja, which came from philosophers and scientists, also in a way contributed to taking what was a ritual icon in a specific regional context to something which had a wider resonance even in contemporary times. And this is a beautiful Nataraja from Thiruvalangadu in the Government Museum, Chennai. And this is the same image that Kumaraswamy wrote the celebrated article, and this was on the cover in that, on Dance of Shiva. And that article, which I had of course touched upon in the first talk, which talks about the balancing of smriti, of srishti and samhara, creation and destruction, and also the five panchakritya, the five activities of the deity, as it were, to balance creation and destruction and so on, which had also inspired other artists. And Rodin also had a good response to Kumaraswamy's article. Auguste Rodin, the celebrated French sculptor, who also wrote an essay, La Danse de Shiva, where he comments on this quality that it looks like, he describes it as une chose divinement réglée, or something divinely ordered. And of course, we know that Rodin is also famous for sculpting the age of bronze and so on. So there was all of this excitement, and there's also been a beautifully cast Nataraja bronze, which was then presented by the government of India to the CERN Cosmic Lab, along with some of the writings of Kumaraswamy. And Fritjof Capra, of course, was a writer who started off as a theoretical physicist, but then, of course, went on to be a more popular writer. And he's used a lot of metaphors also that then became very popular about how the Nataraja image for him evoked a sense of the, the dance of subatomic particles and so on. And he even tried to map a bubble chamber onto the Nataraja image and so on. And all of this, of course, contributed a lot to the popularity. And as Carl Sagan mentioned, perhaps more than other pre-modern traditions, there is some sense of, a premonition, as he called it, of modern astronomical ideas. And he was, of course, also interested in the mention of very long time spans and so on in literature, such as Vedic literature and so on, which he commented on as, the metaphors and the imagination of the time and so on. But anyway, so my interest, of course, had been, because I talked about the casting techniques and so on, but the problem is that many of these images have been cast over so many centuries. And we're talking here, as I said, largely of a solid casting technique, which shows that this is all of, solid metal. So it becomes difficult to have certain objective criteria by which we can actually tell apart the dates of the images. And that becomes quite important also in terms of authenticating bronzes, because we see that many were also recovered from hoards, later hoards, when they were buried to protect them from various factors, including iconoclasm and so on. For instance, Nagapattinam, which was initially, there was a Buddhist vihara there, which was pulled down during the time of the Portuguese, who set up a Jesuit college and so on. And nearly 300 So I had undertaken to sample about 150 representative images from different museum collections, the Victor and Albert Museum, Government Museum Chennai, and so on. And then, of course, undertaken analysis for 18 elements using inductively coupled plasma optical emission spectroscopy. So there were about 18 elements that could be analyzed. And from that, you could sort of build up some trends for the different stylistic groups of bronzes, such as Pallava, which is roughly from about the 6th to 8th or mid-9th century. And then the Chola period, of course, is broadly categorized as Imperial Chola, which is about 9th to mid-12th century. And then you have the later Cholas, and then there is a bit of a hiatus. And then in the Vijayanagara period, Vijayanagara and early Nayaka period, from about the 14th to 16th century, you have a lot of images being made. And although these are often classified as Vijayanagara images, a lot of them are actually found in Tamil Nadu, because the Nayakas and so on were feudatories of the Vijayanagara rulers. And that is also where a lot of bronzes of the so-called Vijayanagara style are found. So, of course, a lot of them are actually made in Tamil Nadu. And in fact, huge numbers when you consider that there were so many temples and so on. And this is just to show you an unfinished bronze. This is what happens when you have all these runners and so on intact. And you see here the sprue at the back. So in the earlier times, they were actually pouring from the back of the image and so on. So different methods of casting, which would have, in this case, it was totally damaged and has been kind of set aside. And of course, each of the castings is quite unique. And here you can also see the impregnation of the mold material, though this is, and you see the lead also in the intergranular spaces. And though, of course, a large number of the Chola pieces were, of course, bronzes, as we saw the tin ranging from, less than about, about, say, the average would have been about 6 to 7% tin and 6 to 7% lead and so on. Though, of course, it varies quite a lot, because the major alloying elements can vary quite a lot. But we do find the use of brass also, particularly in the later periods, which come more into vogue. But we also see some use of brass in the earlier periods. When I'm talking about brass, I'm talking about an alloy of copper and zinc and so on. This is, for example, an example of a 16th century Chera image from Kerala in brass. And you see the inlaying of the eyes and so on. And so here we are actually attempted to do in situ micros, to get a photomicrograph using in situ work, where you do it right on the image itself by taking a replica and so on, because you don't want to actually, cut a piece and damage and so on. But there are all these problems in terms of sampling and the techniques you can use. Now, coming back to the lead isotope analysis technique, which, as I said, I'd managed to use for about quite a large collection, 60 of them. I'd like to point to some interesting cases where you can actually identify the ore sources, because a lot depends on whether you do have the information for that particular ore source. And there's also the question of mixing of sources, because when the lead sources get mixed, then the isotopic fingerprints can go all over the place. But if the lead is from, say, one particular source, or maybe from two sources which have been mixed in a way that gives linear proportions, so there are all these nuances to how you can actually trace the sources. But for example, from this plotting of some artifacts, especially of the early historic period, and some mines, particularly in Western India and so on, you see here that this is, since we have, as I was mentioning, I haven't really dealt much with silver, but you do get the use of silver quite early on, especially in the Gangetic plain, and also going up to the Gandharan region and the Mauryan period and so on. What are described as the punch mark silver coins, which are silver coins which have these kind of markings on them, and so a lot of them were issued, and also from the Beer Mound in Taxila and so on, and these are the kind of typical markings that are found, and some of these are from Koshambi and so on. So you can see here that, for instance, this coin, which is from Vatsa Janapada in somewhere in the Gangetic plain, there is some correlation here with some lead isotope ratios of Ambaji in Gujarat. Yesterday also I had talked about Ambaji and some correlation. And then you do see also that there is one correlation there with somewhere in the vicinity of the Zawar mines or the Riba mines, which is of course the Aravalli region. So that's quite, of course, likely also that the West Indian region would have been exploited early on. And then when it comes to the Shatavahana coins, that's also quite interesting, because yesterday I talked about one of the mines in the Andhra region, Agni Gundala, which was a source for the copper in the binary bronze. And here you find that some of the Shatavahana coins of the Andhra region, they do fit Agni Gundala. But it's interesting that some of the Shatavahana silver is also matching a source in Sardinia, Fluminense. So we do know that in the Roman period, the Romans were also bringing the lead. I mean, the Romans were using lead also as pipes. I don't know, somewhere I forgot to put that photograph in, but if you go to Bath, you see that they've used lead, for pipes and so on, because it's waterproof. And they use it in the galleons and so on. So there was also the availability of that kind of metal coming in with the trade, with the maritime trade and so on. And this is a very spectacular Jain Tirthankara, which is from Gujarat, and this was in the Victoria and Albert Museum. This is a Solanki dynasty here. And this actually was found to have 24% zinc brass. And this also matched, again, the source of Ambaji, which is in Gujarat and so on. And so that's quite a good match. Now, the thing is that with the I had talked about, of course, the extraction of metallic zinc from Zawar and so on, but I should also mention that this is not to say that before the extraction of metallic zinc, brass was not used. There was another way of making low zinc brass, which is that you heat the zinc ore directly with the copper, and so the vapor actually gets into the molten copper. So you could get brass to, with about, say, 25% or so using this process, which we call cementation. But if it is much more than that, if it's a higher zinc alloy, then you know that it was made by alloying directly the metallic zinc. And I did show you yesterday, which I didn't want to put it again and repeat it, that metallic zinc ingot, which had a 4th century Deccan Brahmi inscription, which is also quite interesting and mystifying. But there were some other objects also from the Andhra region that fitted that. But so in this case, when we have so much of a zinc here, it is possible that they were using metallic zinc here. And it's also interesting that we do see some evidence for metals also moving down further south. I have to say that for the bulk of the South Indian images that I analyzed, I could not actually pinpoint readily the metal source yet. Maybe it's just that we haven't got, the full picture of lead isotope ratios across the country and elsewhere. But there were a couple of exceptions which did fit some of the known mines. For example, this 13th century Buddha from Kanchipuram, that was a classic match with Ambaji here. And so this is a similar source. And also some of the Buddhist and Jain images, it's much easier in terms of dating them because they often have donor inscriptions. But the Hindu images, because they were deities, they usually don't have them, which also complicates things. And this Ganesha of the Maratha period, 18th century, that also matched the Dariba mines in Rajasthan, which of course makes a lot of sense because they would have been getting metal also from that corner of the world. And Dariba also is a very big source of silver. We talked about Zawar as having been exploited quite early for zinc, but there is, from Dariba also you had a lot of silver being exploited as a lead zinc source, and they use the cupellation process, which is another method of extracting, purifying the silver from lead silver ores, because the lead tends to then get oxidized out and the silver gets enriched. And that's also, in fact, the basis of the fire assay process. But anyway, even in the absence of, very distinctive ore sources that even if we couldn't pinpoint the ore sources for all the South Indian bronzes, what was quite interesting is that when you look more closely at that larger cluster, you see that there's a lot of smaller clusters forming here. And each of these clusters do have some coherence within them because they all show some kind of stylistic and chronological consistency, which suggests that there was some, it could be smaller mines within a larger mining region which had been mined at a similar point in time and used for metal at that particular chronological point of time, which is why we're getting those clusters. And one thing that seems very clear, for example, is that the Chola bronzes seem to all cluster up here, and the Vijayanagara bronzes of a later period tend to cluster up there. And so this kind of clustering is also useful, at least for making stylistic comparisons. And on the basis of that, for instance, I could reassess some bronzes which had thought to be Chola as to whether they were actually Chola or Vijayanagara and vice versa. So even without being able to pinpoint ore sources in a very decisive way, you still get some pretty useful information. And of course, the lead isotope ratio data had also been then put together with the trace element ratio data. And you find that some of the trace elements such as nickel, cobalt, arsenic and bismuth, even though they are traces, when we call something a trace element, we mean that the composition is less than 1%. But even with that less than 1% composition, there is some affinities with the copper source because they tend to be chalcophilic. So if there is some clustering that we see, then it is meaningful in the sense that it could represent different copper sources. And that's why you're seeing a certain clustering at a particular point in time because they were using copper from particular sources. And based on these aspects, I was able to maybe find a way to tell apart the metallurgical profile of the Chola bronzes from the Pallava bronzes to the Vijayanagara bronzes, and using that I could do some reassessments. Now, just to give a few examples of the images that had been subjected to this kind of analysis, of course, this is a very classic image of Kali from Seni and Vedudi, early Chola bronze, and this also, of course, corroborated very much an early Chola dating, and it has an inscription, one of the few Hindu images which had a paleographic inscription. And again, it's a leaded tin bronze, 6% tin and 6% lead. And there is also an inscription of Aditya Chola of the 10th century, which mentions the worship of Nishumba Sudhani, which is a fiercer form of the goddess killing the demon Nishumba and so on. And you can see that there's a marked difference from the profiles for the Vijayanagara period bronze. This is a Rama of the Vijayanagara period, and that typically fitted this ellipse up there. So it had very different metallurgical profiles, and here you see him here with a bow. And this image, of course, had quite a lot of zinc in it, 21% zinc, brass image. So it did seem that more of the brasses were coming later, that there were some exceptional early brasses as well. And you can see here also this typical depiction in the Hajara Rama temple in Hampi of the 15th century of Devaraya's time, where you show Rama prominently with a bow. Now, another interesting facet that came up when one looked at the iconometric proportions, I talked about the use of the Talamana canon in the iconometric modeling and so on. And it was found that I could identify a late Chola piece of Rama. And of course, Rama worship was known in the Chola period also. You do find processional images of Rama. And so this is a 13th century Chola piece, which fitted the metallurgical profile for the late Chola pieces that I was talking about. But here you find that they have used what is called the Ashtatala canon, or the 8-tala proportionate system. And the 8-tala proportionate system is something which is applicable more to an ideal man. But when we come to the Vijayanagara period, and this is of course a Rama of the Vijayanagara period, which has then been fingerprinted also to the Vijayanagara period, that image is now in the Victor and Albert Museum. And you find here that the iconometric proportion is now of the Dashatala, or the 10-tala proportions, which is more to do with major deities like Vishnu. So, I mean, as an art historian or a researcher, one can conjecture. So one possible explanation for this is that there is a shift in the, the status of Rama worship going from the Chola to Vijayanagara period, where Rama is more of a minor processional deity, but in the Vijayanagara period, he becomes a major deity, and you also have a full-blown temple for Rama in the Vijayanagara period. So you can attribute it to some kind of shift in worship practices and so on. Now, one of the interesting aspects also, which I thought I would just touch upon here, because I had talked about the use of the solid casting process. And here, for example, this is a Pallava period bronze of the 7th century. And you see here what the radiograph shows you of a solid casting. It is completely solid cast. And it's also interesting, of course, that in the Pallava period, you can see with the famous seaports at Mamallapuram and so on, you do see the evidence for maritime contact moving across to Southeast Asia. And for instance, the Pallava Grantha script and other South Indian influence also start coming into vogue in Southeast Asia. And this is also interesting when we look at this aspect. In the last slide also, I had shown you that already in the at least by the middle of the first millennium BC, there were these connections that we could see in terms of the styles of the heightened bronzes moving across and from South India and Southeast Asia and so on. So when you come into the Pallava period, you also see some kind of iconographic parallels in some of the bronzes that are found also. For instance, this is in Java, and you see it's a similar kind of style to the Pallava Vishnu with the limbs and the kind of delineation, similar to the Pallava Vishnu, though in this case, some of the Javanese bronzes are Buddhist. And we saw yesterday also a very beautiful Buddhist Maitreya bronze also from the Pallava period. But this is where the analysis also can be quite interesting. And this is an Avalokiteshvara image, which is found in the Krishna Delta of the 5th century from the Andhra region. And so I had done a lead isotope analysis of this, and this typically fitted the lead isotope ratios of other artifacts of the 5th century from the Krishna Delta, including that Brahmi, that coin ingot with the Brahmi inscription of the 4th or 5th century. So it's interesting because it tells you that already by the 4th or 5th century period, the Krishna Delta was a very important source of Buddhist bronzes. And then we know that the Amravati style, which is associated with that Andhra region, had also moved quite a bit to Southeast Asia. And the style of the Buddhist bronzes that you see in Southeast Asia was also inspired by the Amravati school. And this is a late manifestation of the Amravati school, Vishnu Kundin or Amravati and so on. So that is also quite interesting, but that these were indeed made locally. So otherwise you might be tempted to say, is this a local bronze, or is it actually a Southeast Asian bronze? But from the lead isotope ratio analysis, I can confirm that this is actually fitting a provenance of the Andhra Buddhist region. And of course, this is just to point out again, you see the influence of the Pallava style also in Borobudur. This is very similar style of the seated image. This is, in this case, Shiva, Somaskanda and Parvati, and very similar depictions of the pedestal and so on. And this image also, I was able to confirm is a Pallava image, 7th century image, which was undertaken by the lead isotope fingerprinting. And this is much more of a coppery image than bronze. And this I could also tell that it's not Chola because of the lead isotope ratio and other fingerprints. And stylistically also you can make out that it's very much in the style of Pallava bronzes, and those slanting kind of attributes that you see in the stone sculpture at Mahabalipuram, and the kind of sashes and so on. So there are some markers. But the interesting thing about this is that the skill of these bronzes, we talked about this aspect of, they do final polishing and finishing. You can make out here that even the runners have been left intact. So it does look like there was no final finishing or polishing, anything done on these images, and yet they seem to have captured all the details very perfectly. So the skill in the casting and so on is something that one can admire. Now, one of the very interesting outcomes of this study was that I would say that earlier we had thought that the Nataraja bronze had actually been formulated in the Chola period, 10th century Chola period, because that's when it is seen more prominently also on the temples, also propagated by the Queen Sembi and Mahadevi and so on. But I did find from the isotopic analysis that there was at least two images which definitely did not fit the Chola trends, and they fitted the Pallava trends. And when you looked at it actually closely, again, it is actually a Pallava image. You can see very similar sashes and so on to what we've seen. It's not in the Chola style. And of course, this image of the Shiva as the dancing Natasha has been attributed to the Pallava period by at least one art historian, late Nagaswamy. And that is also because there was an associated copper plate inscription, which is found in the same fine spot, that is Kuram. And what is interesting is that we had thought that this particular depiction of the leg extended in what we call the Bhujanga Trasita Karana, which is associated with the dance of, Shiva Nataraja with the aureole and so on. That particular posture, as I said, we had thought that was only coming into vogue in the Chola period, but here you can already see that it's there in the Pallava period. And there is also a tiny pilaster here in the Siyamangalam temple with this leg extended in this way. And of course, since I had talked about, this interest had also come about with the interactions with the late Dr. Nirupama Raghavan, where she was curious to see whether, this connection that we see in the Chidambaram temple with the mention of Arudra Darshanam, what sort of iconographic correlation there is. And after she passed away, it also carried forward some of this work. And she had tried to plot some of this, the star positions onto the large sculptures in the Kailasanatha Swami temple, and to suggest that that it is following somewhat in the iconographic positions of the Orion constellation. And of course, that kind of idea also does go back to Greek mythology and so on, Orion as a hunter. And this is, of course, much later in the French edition of the Atlas Celeste of Flamsteed, where you see a similar kind of depiction of Orion with something going like that, throwing like that, and that kind of leg, So I don't know where quite that connection is, but sometimes mythologies and ideas also travel quite a lot, not just one ways, but both ways. So I had also carried on that work by undertaking some of this star chart plotting. And this is also a large sculpture here in the Kailasanatha Swami temple. And I also think that this is very unusual with the leg lifted like this. You don't find this posture anywhere else in the Indian subcontinent. The other images of Shiva dancing that you see at Badami and all that are Chatura Tandava and so on. But this particular leg extended in what we call the serpent fright or Bhujanga Trasita. And in fact, here you actually see a serpent under the foot of this dancing Shiva. That is something which is quite unique to Tamil Nadu. So one of the things that I thought might be possible is that this leg being extended could also be because it is pointing in the direction of the star Sirius, which also has some amount of significance. If you look at Vedic literature also, an early form of Shiva is not just Rudra, but also Mrigavyada or Sirius, because the dog star and the hunter and so on, and these kinds of imageries. And also Sirius becomes very important for navigation. We know for the Egyptians also Sirius or Osiris was quite an important star. And it is also one of the stars that some of the sailors use for navigation. And we know that, from Mahabalipuram and from coastal Tamil Nadu, there was a lot of activity of, maritime contact and so on. So observing the star positions, such as these, could have also been an outcome of the fact that they were using the stars for navigation. So, oh dear, I still have to go on to Woods. I'll just quickly buzz past these next few slides on the bronzes. This is also to point out that there are two very interesting bronzes that I had also analyzed for lead isotope ratio analysis. One of them I discussed yesterday, and I talked about how this was made by the mercury gilding process, and the fact that this is by and large a copper image with just 1% of lead, and that's also quite sensible because lead is not a very good element to add if you're doing mercury gilding, because the mercury amalgam that you apply with the gold, you then have to burnish it to burn off the mercury. And so if you have a lot of lead, the lead will also start oozing out to the surface. So that's why it's better to use a copper alloy and do the mercury gilding. So this is a gilded Nagapattinam bronze. And this fitted the late Chola period that, the trace element and fingerprinting trends that I talked about. And that was quite interesting because, again, there is a lot of confusion because we know that Sri Lanka, of course, was a great Buddhist center. And we generally seem to think of Tamil Nadu as mainly producing only Hindu bronzes, but there were a lot of Buddhist bronzes and Jain bronzes also being produced. And we know of Nagapattinam being a great Buddhist center in Tamil Nadu. And so this is quite likely then a Nagapattinam bronze. And I've also put here another beautiful example of a gilded bronze, which is right here in Karnataka of about the 10th century, which is inscribed. And this is a gilt Lokeshwara image. Now, the interesting aspect was that this is a very celebrated bronze in the British Museum, which, and if any of you have been there, it is one of their star bronzes. The Tara image, or it is either Patni Devi or Tara image, which was found in Battikoloa in northern Sri Lanka. And I found that the lead-isotope ratios for this image actually was very close to the Nagapattinam bronze. And in fact, the trace, it didn't seem to fit that well with the Sri Lankan examples. And you also find that the Sri Lankan bronzes quite often have quite a significant trace of iron, which I never see in the South Indian examples. Although you do have a very important copper magnetite ore deposit in Sri Lanka, but it seems to me at least that the iron traces being very low in the South Indian examples suggest different sources. And there is the possibility that this had some connection with the Tamil region, and you can also see that in the modeling that hit flexion. Whereas, of course, this is a typical silver Tara, Sri Lankan Tara, which is a very beautiful example. But the Sri Lankan Taras have a slightly different, perhaps, attitude. Whereas here, this Bhanga, which is very prominent in the Chola pieces and in the sculpture, you see that carrying forward also in this image. So there are these many examples of syncreticisms. And this is a very early Buddha also from Tamil Nadu, from Kaveri Pattinam, which goes back to the early Common Era. And we also have the famous Buddhist epic, the Manimekalai, which talks about the Buddhist worship in Tamil Nadu. And speaking of Southeast Asia, of course, another very intriguing example is that all the way in Cambodia, you find at the Bhyantishrai temple, there's a very fine frieze of the dancing Shiva. You see some inspiration also from Badami here, Chalukyan Badami, because you have this Miravu player sitting here, drum player. But lo and behold, you have this Tamil poet saint Karaikal Ammayar, who's a 6th century Tamil poetess, and she is depicted in this way as a kind of old woman and as a hag, because the myth goes that she prayed to Lord Shiva to turn her into a hag from a beautiful woman so that she could follow him in his dances, in his trance dancing, across the cremation grounds and so on. And that's also quite evocative. And of course, Karaikal Ammayar is supposed to have come from this coastal port town in Karaikal. So it's quite interesting that this resonance, which is found all the way across in the Khmer region. And of course, this is a very stunning bronze of Karaikal Ammayar, where you can see the beauty coming through, even though it's such a depiction of an emaciated woman, that real character, which I find is quite extraordinary. And she's playing cymbals. And that is attributed to this famous Chola queen, Sembian Mahadevi. And I was able to analyze this image of Karaikal Ammayar, which is in the Victoria and Albert Museum. And this image also fitted the trends of what I would call the later Pandyan period, which is, just before the Vijayanagara bronzes commence and so on. And this had quite a lot of lead in it, as much as 20% lead and 3% tin and so on. So this is just to give an idea of some of what we can do with the analysis. And very quickly, since we were worrying about where the tin is coming from, because we famously know that Southeast Asia really is a place where even in contemporary times, there's a lot of tin. And in fact, a bell maker in Nacharkoil, who I had interviewed in 1990, he also mentioned that from his memory, the tin came from Malaysia. And so, of course, it's possible by the later times because we have records, for instance, of the Arab trade and so on with Southeast Asia and tin and so on, which would have also been coming to South India. But interestingly, I think in the very early periods, even some minor alluvial tin that was there in the Indian subcontinent could well have been exploited for making bronze. So it's not necessary that we need to see everything as having come from Southeast Asia. And for example, I found some really interesting evidence from the Kalyadi workings in Karnataka of bronze slags which had tin in them, and these were actually bronze smelting slags because you had a lot of metallic iron, and so much of metallic iron can only form when you've done smelting at very high temperatures. So these were some ores, some bronze ores which had been, some tin containing ores which had been smelted at very high temperatures to get these kinds of bronze slags. So I think once we do more of the archaeology, we get more ideas. Oh, I don't have much time for iron, but then anyway, I just try and do my best in the next 15 minutes or so. Well, I could not, as I was saying, there are many recent excavations which are coming out of very interesting evidence in other parts of India. For instance, Sanauli, which has yielded this evidence of chariot burial with, of course, these are solid wheels, but there is some copper encasing, and then the copper antennae swords, and there is a lot of connection there with the copper hoard culture of the Gangetic Valley. And I mentioned also Mailadam-Parai, where we are getting very early AMS dates for iron, and this is actually a sarcophagus here in Mailadam-Parai with some of these urns and so on. And this goes back to at least the AMS dates here have been sent out, and so we've got these dates around 2000 BC. And this is a sword here from one of the megaliths, though we haven't been able to analyze that yet. And I mentioned briefly about the Delhi iron pillar, and of course, one interesting aspect is that the inscription which is in Gupta Brahmi actually mentions the lofty standard of the divine Vishnu, which was sat on the hill of Vishnupada. So late Professor R. Balasubramaniam, who was a very keen person working in those days in archaeometallurgy and who sadly passed away, so he had proposed that this Vishnupadagiri refers to the top of the Udaygiri mountain, where you have these Gupta era caves, and you see this very spectacular Varaha, and this is of course a gold coin of the Gupta period. And one of the interesting aspects about the Delhi iron pillar is the corrosion resistance, and he had suggested that this is also due to the fact that, well, not just he, but some other scholars, like it had been analyzed earlier also, and even Hadfield had analyzed the Delhi iron pillar, and they found that there was some significant traces of phosphor of about 0.2% or so, which could have contributed to the corrosion resistance of the Delhi iron pillar. And that's not the only, of course, the Delhi iron pillar is more a ceremonial pillar, so it doesn't have any real functional use. But interestingly, there was the use of iron for functional purposes, for the tensile purposes, tensile strength of wrought iron in the Konarak temple. And there were at least about 200 wrought iron beams which were used in Konarak. And of course, here the stone that is used in Konarak itself has very poor tensile strength. And this is, of course, datable to 12th century. So you see these iron beams are being used to reinforce the lintels in the ceiling and so on, so that they are load bearing and so on here. And many of them have now been taken out and lying around. And these would have been made of a similar process. So this is to point out some of the, I had pointed to this site, Kadibakle, where we found very early higher carbon steel. And of course, this is just to show you what normal mild steel or wrought iron would look like. This has about, you see the normal ferrite phase. And what I was trying to tell you with the sample that I already showed you, that had much more of the pearlite phase and almost no ferrite. So that is how you can tell a high carbon steel from a low carbon or wrought iron, what you're seeing here. This is more along the composition of what you would find in the Delhi iron pillar with the slag stringers and so on. And then, of course, I touched upon the wood steel, and I just show some of the evidence from some production sites that I had been looking at. And this is quite interesting because this particular phase diagram, you can see how many people's studies have actually contributed to building this right across the late 18th to 19th century. And so now we understand better how actually what causes the properties of improving, what happens when you add carbon to iron and how it improves the properties. I spoke about wrought iron, and that typically has less than about 0.04% carbon, and that's a very ductile, and so it's used for forging quite extensively. And the interesting aspect about the wood steel is that, as I said, it was an ingot of about 1.5% carbon, and that is typically made by carburizing wrought iron along with carbonaceous materials so that the carbon got into the steel and then improved the qualities. And then I spoke about this typical banding of perlite and cementite, which was also sought after, apart from the properties of the steel itself. And it's interesting that the term that is used to describe the steel in South India, woods, may derive from urukku, which is an old Tamil word, which actually refers to the process of melting. And you still hear that being used by craftspeople and so on. And in the Sangam poetry, you also find this a variant of the term yegu and yeku and so on, which is used to describe spears. And as I said, we now see from the dates from Kodumanal and so on that it does go back to at least about 5th century BC that they were using the wood steel process here in South India, as I'll show you. And this was, of course, from a book showing this Tamil poetess Avayar, who mentions the spears used by the chieftain Anchi and so on. And this is typically the remnants from some of these crucibles which I had uncovered at a site called Melsiruvalur. And you see here that the composition is very typical of what we call ultra high carbon steel of about 1.5% carbon steel, where you have the perlite network forming within this honeycomb network with prior austenite going all around. And the thing is, this structure can only form if the steel has been actually solidified from the point where austenite had formed. Otherwise, you wouldn't find this honeycomb being formed. So that means it has reached very high temperatures here. It has gone into these temperatures of at least about 1200 to 1300 under very reducing conditions for this remnant austenite to be formed. So it tells you that and even the globular structure tells you that it was practically molten. So the fact that they were able to achieve this kind of molten carburization is very significant and as a high temperature process, which was difficult to achieve in antiquity. And of course, you have the accounts of travelers such as Tavernier in 1679, where he talks about thousands of ingots being traded from the Hyderabad or Golconda region and so on. And this is one of the Kamaris, Ukku Kamaris, who's no more now, Mandaloji Gangaram, who's holding some of these wood ingots. They were just lying all around, the slag heaps, the blacksmiths and so on were just living amongst these slag heaps. And this is typically what one of those ingots looked like, and the crucible fragment here. And Francis Buchanan also in his travels through the Malabar had done quite a bit of documentation of the wood steel and ironworking and wood steel forge as well. And you see here his illustration of how the crucibles were packed in here with the carbonaceous material, and then these are the very big buffalo bag bellows and so on used to fire the crucibles to a long firing cycle so that the process of carburization and so on would take place. And of course, there are many nuances to it, but it calls for a whole topic in itself. But what is also interesting, of course, is that the wood steel process also was used to make these Damascus blades, and that captured the imagination also quite a lot in terms of the popular narrative. And in fact, Sir Walter Scott, in the book The Talisman in 1825, he fictionalizes this encounter in the Crusades between King Richard of England and the Sultan Saladin, who is said to have sliced a pillow with his superior sword, which he described as having 10 millions of meandering lines, which was basically a Damascus sword made of wood steel. And what that was actually referring to is this damask patterns. As I said, what happens when you forge an ingot of wood steel is that you get these patterns of alternating perlite and cementite. And when you etch it, you get these kinds of patterns. But apparently the edge that you got from the Damascus steel blade was so good that he showed that it could cut. In some versions it's a cushion, in some versions it's a handkerchief. So it had a very, very good cutting edge. And of course, since I was mentioning Francis Buchanan's accounts, from Tipu's time, we do have some very good examples of Damascus steel blades. And here you're also seeing the hilt here from this blade from Tipu's time, which is in the Clive Museum. And you see here, of course, the famous tiger motif that is associated with a lot of artifacts from Tipu's time. And you also see the use of the Koftgari technique, which is a gold damascening technique, which is also a very sophisticated technique, which comes from the influence from the Persian and Ottoman world and so on, where basically the gold has then been sort of damascened onto an iron base and so on. So there are many of these kinds of techniques. And coming to the material science interest in wood steel, it is interesting that a group in Stanford led by Oleg Sherby found that a particular class of alloys known as ultra-high carbon steels were found to exhibit superplasticity or high formability at high temperature. And this was then patented. And it's only later they realized that this composition was exactly the same of the Wootz Damascus steel. And the interesting aspect about the superplasticity means that this could explain how they were actually able to work the wood steel blades to such a great extent, because you do find, for example, some Parisian bladesmith who took and wood ingot, he says that it is really not workable and so on. But this is because they were able to work it not at red heat, but at a slightly lower temperature where, the superplastic properties could be exploited and so on. So the bladesmiths were aware of how to work these ingots, which the Westerners who were encountering them were still trying to figure out how that was done. And you can see also here that this lamellar structure of perlite and the honeycomb cementite, as it gets progressively worked, it gets spheroidized. So you get the spheroidization of the cementite, and that also is what gives the properties of superformability and so on. And you also see how this hypereutectoid structure actually corresponds to what I showed you from that production site of Melserevolur and so on. So you can see how using traditional methods as well, they've made quite a sophisticated product. And of course, in recent times, there's also been a lot of interest in the Wootz blades, because the studies by people like Poffler have suggested that the blades also have nano-wired cementite, which is carbon nanotubes, and that is also what contributes to properties and so on. So there's a lot of interest and momentum in those directions. And since Spenta had also been asking me about, what about ordinary objects? I think if you actually looked around, there would be a lot more we could find from the record of agricultural implements for the use of woods, but we need to go around looking at those. This was, for instance, a toddy tapper's knife, which was in the possession of one of the blacksmiths. And of course, cutting toddy is actually very skilled, because it's quite hard, the sap, and to get the sap out and to cut the stem. And so you find that the toddy tapper's knife has classic hypereutectoid composition of ultra-high carbon steel. And that's also confirmed from the scanning electron microscopy and so on. And this is a very nice mural in the Tipu's Darya Daulatabad palace, where this shows the Nizam of Hyderabad with the Shamsher and so on. And I've shown some of these photographs again. And coming back to the production sites and the dates for the Wootz crucible steel production. So as I had been mentioning, this had been a site that Professor Rajan had excavated, and now the dates go back to 5th century BC for Kodumanal. I'd shown some of the diamond drilling and the quartz beads. And you also have these tuyeres and crucible fragments, which are very similar to what I found from Melserevolur. And the crucible fragment, when you look at it by scanning electron microscopy, it seems to be, again, ferrous rich. And some of the implements found also, you can see the structure similar to ultra-high carbon steel of the cementite network and, bainite and perlite and some of those phases. And another interesting aspect is that around this region, Kodumanal is also referred to as Kodumanam in the Tamil Sangam literature. And of course, the Sangam literature also mentions the trade with the Yavanas or the Mediterranean people. And there are also Roman accounts which talk about the iron from the Ceres. And some scholars have thought that the Ceres might refer to the Chera kingdom. And in fact, Karur, which is very close to Kodumanal, also was the former Chera capital, which is near that region. And you also have other evidence of this Roman trade. This was a beautiful gold signet ring from Karur, though it was in a private collection and gone completely missing. But you see here how the Indian and Roman motifs in a way combine. It has a shape like a Roman signet ring, but the theme is very much like Indian, the Mithuna couple and so on. And another site of interest here now is the Muziris Pattinam, which again was a significant site for the Indo-Roman trade. And you see, for instance, this beautiful carnelian intaglio of the Roman goddess Fortuna, and there's a wharf here at Pattinam. And some of the analysis that I showed, again, confirmed the nails having typical hyper-eutectoid structure of wood steel, 1.5 wood, carbon wood steel. And apart from those kinds of steels, there were also other weapons being used. And it was very interesting because when I was interacting with this cutlery master and his daughter also, who's an amazing cutlery exponent some years ago, and you know, the urumi, which is that coil blade that they use in the cutlery repertoire, and these were some of the last bladesmiths working with it. And the composition is really what we call, it is a higher carbon steel, all right. It's perlitic, 0.8% carbon steel, but it is what in modern terminology we call spring steel. And this is, of course, what was then used for clocks and so on. So this is typical spring steel here. And of course, by you know, the 18th century and so on in the West, they were using spring steel also for clocks. And of course, you also see here this depiction of all of these implements in some of these Chola bronzes, this martial goddess. And a lot of the women also were exponents of Kalaripayattu, such as Uniarchi in the past. And another interesting observation made by Francis Buchanan, where he talks about the steel-making forges, which were used to make strings for musical instruments. And again, if you look at the mural in Darya Daulatawag, it's quite interesting because you see this set of musicians. One has got the tanpura, and one has even got a violin somewhere and so on. So it's quite interesting. And so it's possible that some of the steel that was being made there, and of course, it would have had to been extruded to a great degree, but it could have also been, at that point, being used for musical instruments. Though, of course, in earlier periods, they would have used gut and so on. Well, of course, many of the sword blades and so on of the Wootz armory were all destroyed just following the mutiny in 1857. In the Sepoy mutiny, the Indian armories were destroyed by the British. And this is quite a fine sketch by one of the well-known illustrators here in Bangalore who worked on our book. And they say they even developed a special shearing machine to break down all the Wootz blades. And so this is just a conjectural kind of picture. But the other amazing story, of course, is that so much of material science work had been done on the wood steel, which in a way is quite a remarkable story of transfer of technology as well from east to west. And for instance, Faraday had undertaken a lot of work on the Wootz ingot, and that also paved the way for his discoveries on alloy steels and so on. And in 1825, it was Mouchet who recognized that the Indian process is basically the action of carbureted hydrogen gas and so on. So he was able to identify what was actually contributing to the properties, that it was carbon. Because, you know, carbon actually was one of the elements which was identified much later, because it's not a very tangible sort of material, because a lot of it is an organic material and so on. And in this case, when they're using organic matter to carburize, so that's also why so many of these Western scientists weren't able to, for some time, really figure out what was the alloying element. In fact, Briand in 1821 did some 300 experiments to understand the composition of woods. And he tried to even alloy uranium and palladium and so on. But he made a lot of seminal contributions through that on the microconstituents and contributed to a lot to the study of modern material science. But it was Lavoisier in 1772 who showed that diamond also was a form of carbon. And then Tobin Bergman in 1781 studied the different compositions of cast iron and steel, though he attributed the variation to what he's described as plumbago, which we later know was steel. And another important aspect was the cutler, James Stoddart, also worked with Michael Faraday on replication wood steel. And he was, of course, a manufacturer of surgical instruments, and he found that Wootz was excellent for making surgical instruments. And I have seen some very nice examples of scissors and so on from Ottoman collections, which I think they're all Damascus steel. I saw that at a very beautiful exhibition in London sometime, and you can see gold damascene. So I think certainly in the Ottoman period and so on, they were using a lot of instruments which were of crucible steel. But it's also interesting in the light of the fact that you have in India also the accounts of early surgery and so on attributed to people like Shushruta and rhinoplasty and so on. And so whether in the archaeological record we can actually identify any surgical instruments also of iron and steel, from earlier periods, something is something to keep in mind. Because certainly from Taxila and the Bhir mound, the Gandharan site that had been excavated by Marshall, there were a lot of copper instruments which were found, which have been labeled for various regions as surgical tools, which seems one plausible explanation. And I think I have just, this slide, of course, is just to show you, again, the kinds of techniques to reconstruct the process of wood steel production. This is a crucible from the Telangana region, and this is the scanning electron microscopy. And you see here these, the elements of the regions where you find the metal concentrating. And what was quite interesting is also you see in these crucible fabrics also there was quite a lot of traces of zirconium minerals, just tiny specks and so on. But that also could have been added from some of the sands, and some of the sands do contain zirconium, which can also contribute to the refractory properties, because you need to have a crucible which can really withstand very high temperatures, and that's why they were often also packed with quartz and so on. And you also have these relics of rice hulls, because rice hull relics, they also contain a lot of silicon and carbon, and again, they contribute to, adding carbonaceous material as well as siliceous material, so that it contributes to, increasing the refractive capabilities. I mean, there are a lot more nuances to this, because we think, in fact, this is another process here going on, which is not the just carburization of wrought iron, but actually decarburization of cast iron to, an intermediate steel of, which is more, comes down to about 1.5% carbon steel. But these are all, which is also called the Decany process, but that'll be going on forever. And lastly, I'll just touch upon another of our ongoing studies, which is also another example of the transfer of technology from east to west. Of course, we know that in the Tipu era, rockets were used in the Battle of Poliur against the British in 1780. And according to the Battle of Seringapatanam, a single rocket is said to have killed about 3 men. And some years ago, these were several of these metal case rockets which were found in the near Nagara, near Shivamogga. And we had been able to analyze in the team with Shejeshwar Naik, the then curator, and Nidhin Olikara, and some of the labs, Divakar and so on. And we use this spark source mass spectroscopy and so on. And of course, this is a typical mild steel, 0.2% carbon and so on. But it's really very interesting how they've managed to roll and extrude this. And this was already in the earlier part of the 18th century. So it's quite interesting how they managed to do it, and we're still studying it. And of course, the rockets were mounted onto bamboo sticks along with gunpowder and so on. And apparently they could travel about 1.5 kilometers as well. So there is, of course, a lot more to be studied. And, it seems now that more examples are coming up as well, maybe in earlier periods as well. And we know that William Congreve, who is credited with the modern invention of the rocket, actually studied a lot of samples in the Royal British Arsenal. So, and of course, this is a very beautiful example of a ceremonial cannon in the Bidar region. And we at NIAS also try and do some experimental iron smelting. As you see here, this is a model of the Agaria iron furnace, the traditional iron smelters from central India and so on, that we are trying to replicate here and so on. So it's a very vast and nuanced topic, and it's a great pleasure to have been able to at least share some, sort of maybe scattered vignettes here and there, which would at least try and evoke more interest and support for such research. So thank you.
The Chola architecture and the Pallava architecture, what is the difference?
Sorry?
You said there's a difference between this sculpture and another sculpture. Because this is not Chola architecture, this is Pallava architecture instead. What's the difference? Yeah,
well, of course, you have to be an art historian to understand the differences, but you're talking about the bronzes or yeah, so the bronzes. So the Pallava bronzes, they have, the thing is that one way of art historical dating is to compare with the stone sculpture. So when you look at the Pallava bronze, it is a lot like the sculpture that you see in Mahabalipuram and so on. The same kind of, the attributes are always slightly slanted, and even the sashes that are worn and the kind of modeling, very kind of slim and so on. So when you look at the representation, and the attributes, there are those kinds of similarities. Whereas in the Chola period, as I said, these are visual differences, but the important thing is that the temples have datable inscriptions and so on. The bronzes themselves don't. So if you compare them with the sculpture in the temple, which is dated, that's one way of fixing the chronology for that. And the Chola pieces, for example, that Pallava Nataraja, which I identified as a Pallava Nataraja, there's a forward-facing Apasmara. I mean, Apasmara is the dwarf demon on top of which Nataraja is supposed to dance and associated with ignorance and so on. And usually in the Chola pieces, he is sideward facing. But in the Pallava period depiction, you see he's forward facing. And that you see mostly only in Pallava pieces. You don't see that in the Chola time. So there are some of these markers. I don't want to give them all away because they're part of our knowledge. Yeah.
Pandya period sculptures.
Yeah.
Pandya period is also, same time as Chola period, right?
Well, the early Pandya period is, so again, now there is a regional difference there as well, because then that is shifting to another region. And why I called, see, what I also try to do in this classification is look at the most prominent dynasty at that time and the images there. So what we call the later Pandyan period is when Madurai again comes to the fore, like in the 13th century or so. I mean, you do have the earlier Pandyan period, but at that time they were all of these, so maybe they were not so prominent. But let's say in that period of the 13th century, if the Pandyans were more prominent than the Cholas, because the Cholas have subsided a bit by the mid 12th century. So it's then a lot of the attention shifts to Madurai as a capital. But then that is also around the time that you have Malik Kafur's invasions also and so on. So again, there is a bit of a hiatus after that. And a lot of bronzes actually got buried in hoards at that time. So, but then the later Pandyan period, so there were, and you do see also a lot of bronzes which in a way fit the styles that you associate with the Madurai region. There's a particular way of depicting the nose and so on. And, also the themes they depict, for instance, the marriage of Shiva and Parvati, Meenakshi and Sundareshan. You see some of that with the Prabhavali, which looks a lot like the stone sculpture of that time. So it's a bit of a nuanced thing. You have to compare the stone sculpture, you have to compare the inscriptions and various other, and what is the iconography, which kind of temples, or which deities were being worshipped. And also what I found actually was useful was that since there were some copper plate charters which had inscriptions like the Pallava copper plates and the Chola copper plates, and also the coins, and some of the Jain and Buddhist images which did have these votive, donor inscriptions. So for instance, that Kanchi Buddha, that is again a typical what I call a Pandyan, later Pandyan image, and it does fit the trends for that. And if you see the kind of style, that face, it is rather similar to what you see in other later Pandyan images, even amongst the Hindu bronzes. So what I'm saying that whether they're Buddhist or whether they're Jain or whether they're Hindu, at the similar period, they have similar facial features. You see? So it's as if the similar craftsmen were working across these different religious or faith denominations. So in that sense, the craftspeople were, I think, working in guilds moving across these different faiths. So that is also one way of fixing. Or for instance, if you see a Chola Buddha image, it is similar to a Chola Shaivite image or whatever, the same kind of style and so on. Likewise, you saw that with the Pallava image also. A Pallava Vishnu and a Pallava Buddha looked quite a lot similar, not much difference. So I think across the religious denominations, there's not much difference in the craftsmanship, which is, again, I think quite interesting in a way. But anyway, thank you for asking that so that I could refine that.
Just commenting on this dance of Shiva idea, like the Tagore also has a beautiful song about this, that the dance of Shiva tamed the atoms and the stars and the moon dance around your feet.
Yeah.
It's a beautiful song like that, which is a sort of interesting combination of science and
Yeah,
art.
I mean, definitely it seems to have been there in the imagination of the devotional poets and so on, which may be why we see it also then coming into the sculpture, because as I was saying, there's this verse also by Manikavachakar where, he says, he dances, creating, destroying this heaven, earth and all else, and, Adiyum Antam Illadavar, the one who's without beginning and end and so on. And I think there's also some poem from Vardnagar which describes the scattering of the stars and things. So there is some vision of some connecting with perhaps more in an intuitive way, connecting with cosmic phenomena or whatever, not in a very, I wouldn't say, it's more in a metaphoric and poetic sort of way, of course. Because also, and this sense of maybe going beyond the form into some kind of abstraction, there is the form, but then you also transcend the form, because, Manikavachakar, for instance, sings, when will I get to gaze upon him, the one who is earth, wind, water, fire, and ether, because again, Shiva Nataraja is connected with the 5 elements and the Panchabhuta and that kind of thing. So in a way, it's very intensely visualized, the bronzes, but there is that quality of somehow something that is transcendent or beyond vision, so to speak, something that inspires, so that I think is also there in terms of motivation of the craftspeople. And the fact that Ganapati Stapati himself told, he's gone on record saying that they've actually visualized the iconography within the star positions. So some sense of connecting to, something which is beyond, connecting the human and the cosmic, or the divine and the human and the cosmic, and that kind of thing, yeah.
So I just wanted to ask, which century is this cannon from? The Bidar Fort?
The Bidar Fort?
Yes, I mean the cannon.
The cannon. Yeah, this is typical Bahmani, 14th century or so, yeah.
Because it seems very well preserved, right?
I would say it's preserved, but one does worry because it's just lying out in the open and kind of open to the elements and so on. So, but at the same time, I know actually moving it from that it would be a shame as well, because it's so cynic to see it like that as it is. But preservation, yes, the thing is, of course, with the Delhi Iron Pillar also, the reason why that they had actually over time in the Indian context been able to make iron which preserved quite well. I mean, I wouldn't say it's totally rusty, but as we know with the Delhi Iron Pillar, the great thing is that it is very highly corrosion resistant. But that may have also been the fact that in the traditional bloomery process, you did naturally itself also get a bit of phosphorus coming in because of the kinds of, you're not using a lime flux, which they would have with cast iron, you need to kind of raise the temperature, so you start using lime as a flux and all, but they didn't use that kind of fluxing in these shaft furnaces. So it's also because they were using a kind of, I won't say primitive, but a kind of earlier kind of technology, which in itself also managed to get some amount of the phosphorus from, the leaves and organic matter into the iron. And so that phosphoric iron, as we call it, with about, 0.2% carbon or something, that would have 0.2% of phosphorus, not carbon. That would have actually contributed to preserving the iron. And you also see that, for instance, in the Tipu rocket also. That also has a trace of phosphorus, but I think more studies need to be done on that as well. And at least I don't know if anyone's actually taken a sample of the Bidar cannon and so on, but several examples of those. But these are all wrought iron, they're not cast iron cannon. Each ring has been wrought and then assembled. So there's a great deal of skill in wrought iron cannon making and all that. I mean, Tanjore is another great example. There's this huge big cannon which is again outdoors. So, and many of them, of course, were ceremonial after a point, but anyway, the skill of wrought iron did continue for a very long time as well. So.
These pillars, I think there's one in Allahabad Fort also, I think. So there are several of these, I think. They were probably built at the same, constructed.
And so on, yes.
So if there were these big monuments which were reproduced and not, wouldn't there have been also smaller ones with the same, smaller maybe implements or deities or others with a similar composition or similar properties? Have there been any?
You mean more of ritual use of iron artifacts?
Or any other way in which the similar iron of the similar composition shows up, not just in these monolithic pillars? Are there any
Yeah, well, of
other
course, the wrought iron
objects?
beams are also made of the same way, the ones that I showed you at Konarak. And I believe there were some wrought iron beams also which were reinforcing some of the Pallava temples, though I have to kind of explore that a bit more. And sometimes iron dowels have also been found in Badami and so on. But I think also, you know, the problem with iron that since it corrodes a lot, so actually doing an analysis and getting, you know, making sense of it is not that easy. It's much easier if it's wood steel or something, because then you have a structure and it preserves also, you know. So, of course, the other thing is, I don't know how much has been systematically kind of catalogued and studied. But, you know, now that you're asking me from, I remember a long time ago from the Tamil Nadu State Archaeology excavation, I have actually seen a Mother Goddess figurine in a ferrous material. And actually, it seemed also very well made. It could have been a higher grade steel as well. But I don't know, unfortunately, quite often, you know, things which are excavated, it's hard after that to find out, you know. I think we need to get more of these being put into museums where we can study them or whatever. So, and I'm sure you're right that the record actually would probably yield more of interesting little artifacts and so on. For instance, objects could be labeled as some kind of alloy when it may well not even be that alloy. It may be something else. Unless you actually studied it, you wouldn't know, you know, that kind of thing. And of course, you do also get the, I find that now that you're asking me, some of the Chera coins actually have quite a lot of iron in them. They're quite high in iron, whether that was because of the ore they were using. So I think we just do need to actually study a lot more and get to the bottom of that. Yeah, thanks.
I have a question. I mean, see, in these 3 lectures, in the first talk, you showed us a figure of a buffalo. But in your entire discussion, we didn't see a cow at all. Neither in sculpture or in, you know, the metallurgical figurines, or any explanation for that, or, you know, that's a very...
Yeah. So I tend to, you know, restrict myself to making inferences on the metallurgical side, on the symbolic dimensions. That's true. Well, yes, of course, you do have it in the literary, I suppose, ways and so on, and the cows and the Kamadhenu and so on. I mean, you might see some folk toys like in you know, the toys that you see in North Karnataka, Kinal and so on, you know, of Kamadhenu. But you're right that there may be a few of this particular divine cow, Kamadhenu, but that I've seen only early, I mean, recent examples. I can't say that. Or I might have seen something like that in maybe some Nayaka sculpture, late sculpture. But to that extent, I don't know how widespread, or at least at that point in time, in the earlier times, all of that kind of, you know, thinking was. I mean, to the extent that they were with pastoral communities, they would have always placed a lot of value on the cattle and that kind of thing. But seeing depictions of that kind, it's definitely much more of, you know, depictions of the bull. You're right. Something to think and reflect on. The male of the species.
I guess Nandi was because of
Yeah.
Nandi, there was probably a natural bias towards associating.
Yes. Yeah. Yes, that's right, because it's usually Nandi which is depicted. And so, but was Nandi then representative of all the bovine, you know, creatures or whatever as the Vahana? Yeah. Well, anyway, as I said, yeah, in that concrete way, I don't think we come across too many representations. We do, of course, in Mahabalipuram, you do see the cow being milked, which is a very naturalistic kind of depiction, which is quite lovely. And that's a beautiful, but it is part of the panel of Krishna, you know, holding up the mountain Govardhana. So there you see the cows and the calf, and also the cow being milked over there and so on. And I think it comes into vogue again quite prominently, quite a lot in miniature paintings, and, you know, showing Krishna with the gopis and the cows and so on. But I mean, in sculpture, not that widely, no, because, yeah.
There's one thing you showed about the British deliberately destroying all the implements and wood, steel.
Yes.
Some documentation of this type of barbarism.
Well, also Egerton also mentions it that a lot of the armories were destroyed and so on, and even from Tangier armories and all. Sometimes they were collecting also and keeping them like for study, but quite often, I think after the mutiny, because they were also, you know, there was that element of fear and so on, and so they thought it was better to get rid of all the weapons and so on. And then, of course, gunpowder and so many other things takes the place of that in terms of controlling populations and so on. So, but so yeah, I mean, and in fact, that there was a lot of setback to the you know, boots making you know, enterprise also from the thanks to the British. You know, for instance, the Kamaris used to get the iron ore from the forests and so on, like in Godavari or many other places. And under the Reserve Forest Act and so on, they couldn't actually access the ores anymore, and mining became illegal. I mean, many of these families and, you know, communities which were traditionally mining and so on, they could no longer do it because it was illegal. So that was another way in which the craft itself died out, because they couldn't get the iron ore. And so, like many of some of the Muddakamaris in the Godavari region, they could actually remember that in the past, you know, their ancestors also used to go and collect the ore and mine. And even the Kotas in the Nilgiris, they say similar things, that they would go and collect the ore from the hills and so on. But all of that stopped after, you know, some of these forest acts and things like that. So, yeah.
So there are some questions from the online audience. So Rukmini asks, thank you, Professor, for your wonderful talk. Her question is, some of the metal statues you showed are in museums, and some of them are in temples made of stone. How are these metal statues embedded in stone pillars? I mean, it remains there for centuries, the stone and the metal.
Yeah, so actually the metal statues are not embedded in the stone pillars in that sense, because in the main sanctum, they worship the, let's say, the aniconic lingam. And so these are processional images which are taken out in procession. So actually you'll see that they had lugs in them, where, you know, poles could be put and they could be carried around, you know, as in procession as Utsav Murtis. Of course, yes, some of them are installed in these shrines and they are kept there, but they're more on pedestals and things like that. They're not embedded in the stone in that sense. So they're just kept on top of pedestals and so on. Many of them are lying in vaults, and then they get taken out during special festivals and decorated for puja and that kind of thing. So yeah, but it's an interesting point. I suppose if one manages to go and see them more often, one would be able to get more of an idea. But you know, the problem we have is that it's not that easy to take photographs of you know, art objects in temples and so on, maybe with good reason, but then that also becomes a challenge for us sometimes, because, you know, you see a lot of very interesting things which you can't, you know, document and that kind of thing. So yeah.
Yeah, she has one more question. This is a bit away from the main topic. Can you say something about musical pillars found in, for instance, in Hampi? What is the technology used there?
Yeah, I think I need a talk on stone as well to deal with that. I have given some lectures about that and so on. So, of course, you know, one thing is that the stone itself in the Hampi region, the porphyritic granite, it has this property that some thinner sections of granite are resonant, because it is it's that particular kind of granite, and the fact that it has a lot of close-packed orthoclase minerals and so on, that also seems to the alignment contributes to tonality. It's a similar reason with the martensitic beta phase that you see in the quenched bronze. It's the alignment of the martensite that contributes to tonality. That is one aspect. But also they seem to have, you know, in some way empirically arrived at a way of generating a lithophone, because it is like a, you know, a tuning fork which you prop it up like that, and if the top is less heavily packed than the bottom, then there tends to be these vibrational modes. So it is like a composite you know, lithophone with colonnades and so on, which seem to have been generated. And I would say there is some intentionality, because you do have, for instance, the, you know, a drummer the sculpture of the drummer just in front of the pillars, which give off a much deeper resonant sound. And then you have a sculpture of the cymbal player in the colonnettes, which give off a higher pitch. So somehow, empirically speaking, they have arrived at ways to, amplify the resonant properties and, generate those resonant sounds and things. So acoustics.
Any more questions?
And there was some vibrational analysis and all done, but it's something that would take more explaining and stuff. Yeah.
So it's been a pleasure listening to you over the last 3 lectures. So let's all join to thank Sharada for a wonderful series of Madhava Lectures.
Thank you so much for this opportunity, and thanks for the wonderful audience and such an inspiring setting to do this, because, I think it's very important to bring into, tie together different disciplines and also have broader global perspectives on history of technology, and, that always enhances our understanding even in contemporaneity, and that's important also to keep in mind, not just from any particular region, but the overall, global dimension of so many contributions, which, in the march of civilization and that kind of thing. So thank you so much, and all the very best to ICTS, and we look forward to further
More
education.
lectures from you, perhaps, with the stone pillars.
Oh, thank you.